So the title of this talk, An Attacker Looks at Docker, Approaching Multi-Container Applications. I think that should show you a little bit about the intent of this. It's an unapologetically red team talk. So there have been good defensive talks on Docker and containerization. The world in which I operate and my teams operate is red team and penetration testing. And so our goal is to quickly get ourselves up to speed with new technologies, and the purpose of this talk is to take somebody who is a penetration testing practitioner or somebody who's learning penetration testing even, and the training and the education that they've gone through to get to that point, and try to apply that to multi-container applications versus traditional monolithic applications. So my background in this, in my graduate studies at Mississippi State University, I helped develop the cyber operations program there for the NSA Centers of Academic Excellence. My research was in industrial control systems with vulnerabilities in human-machine interface software, finding and classifying vulnerabilities in those systems. After a while, as a professor at Mississippi State University, we formed a private company to do penetration testing, vulnerability analysis of hardware systems and embedded systems. We did forensics work and a little bit of everything. And then recently, within the past 3 years, we were acquired by a major accounting firm, Horn LLP, and became Horn Cyber. And so at Horn Cyber, I'm Director of Cyber Operations, which is my made-up title, for overseeing anything offense-oriented. And so that includes our penetration testing, that includes red teaming engagements, and that even includes when we look at applications themselves. And that's important because one of the bigger points for this talk is to say that if you're a penetration tester sitting out there right now, one of the side effects of everybody adopting and going into containerization is that your skills as a penetration tester now make you a pretty decent application security specialist too, as far as looking on the insides of applications for vulnerabilities. Whereas previously your training probably gave you some insight to the internals of applications, but you mostly worked outside of them at the network layer. In previous talks that I've given on this subject, on the subject of penetration testing, involved the operational security of testing engagements. It's relevant to this because some of the tools and some of the processes that we're currently developing for penetration tests, that we're trying to redefine penetration testing. We're trying to formalize the field more, develop tools for doing large-scale engagements efficiently with multiple people, and the development of those tool sets is naturally, of course, now using containers. And so I've had to come up to speed with it. My teams have had to come up to speed with it. And in the process of developing some of these tool sets, we've learned a lot about what it looks like if an attacker looks at these things. And so the intentions for this talk for you to walk out of here with is, I want to make a strong point, and it's not just about the technology, because you're actually going to find that to be very simple here. The intention of this is to make a strong point about the relationship between an attacker's skill set, your skill set, and your development of your skill set over time through training or experience, versus trends in the way developers use new technologies like containerization or any of the other sort of trendy technologies that are out there. And so how do we leverage what we already know, what we trained with, what we have experience with, and how do we look at learning new technologies moving forward? And so the goal is to provide a hacker experience with exploitation and post-exploitation of networks of systems and exposure to the testing of applications that contain multiple containers. And this is compared to monolithic applications. A monolithic application might be something that it all runs on one system. It may all be one code base, one binary even, or a set of PHP files that make up a single web application. There's a lot of different things here, but essentially it's one program flow. It may have forked copies of itself and threads and things like that, but ultimately it's one sort of monolithic program. And to gain insight into how it works, you need to hook into variables. You need to attach with a debugger. You need to be in memory space alongside with it. Whereas with a multi-container application, the idea here is that you can build these things out of Lego-like containers, combined with each other and not have to develop as much. And they can be different technologies. And so My examples are going to be concrete examples with Docker, and there's more examples in the white paper associated with this talk. And the things that I'm showing just leverage common practices in pen testing. The inspiration for this speech is H.D. Moore and Val Smith's DEF CON 15 talk, which is ancient now, but I think it's a classic, Tactical Exploitation. And so they covered sort of a penetration testing in tactical techniques and tricks and tips and things, and it's a very good talk if you haven't seen it. And of course the target audience of this is red team. Now, if there are any blue team members who snuck in here, that's fine too. They might learn something, right? Prior art in this field, there's not been a lot of pure offense talks on Docker and containerization. Mortman, Gratifiore, Bettini, and Cherney, and Dolce, the talks that you see listed on this slide, these are very good talks on the security of Docker, and there's lots of things about the underlying implementation and architecture, vulnerabilities in earlier versions of the platform, talking about targeting Docker developers through misconfigurations of their development environments, kernel capabilities, low-level implementation of Docker. All those things are very interesting, but if we talk about vulnerabilities at that layer of Docker, these are things that get fixed over time, right? And so the nature of how developers use Docker opens them up to way more vulnerabilities than any Docker vulnerabilities in the platform itself that can be fixed by downloading a new version of Docker, right? Or deploying something new there. The Docker documentation is listed on here as a current state. And so if you for any technology, any language, any library, any platform, if you want to know what most code for that platform looks like in a developed sense, look at the tutorials for it, because that's how people learn them. So a developer learns Docker by pulling up the tutorials for it, implementing some hello world type applications, and then they sort of use that experience to build new applications. And so everything starts looking a little bit like the way it's currently implemented. There's good practices in Docker security that these talks go over, that the documentation talks goes over. The tutorials don't really go into it that much. And so you can bet that security is going to be lackadaisical, much like it is in the tutorials. And the tutorials are meant to be like that, because they're meant to be solid, small things that you can develop something from quickly. When we look at containerization in Docker, if you have no idea, and I didn't, going into it, all I knew is that everybody on Twitter seemed to like it very much. And so looking into it, the best way to describe it is that if you remember playing around with chroot jails, then it's kind of like that, right? It's an amped up version of that. Ultimately, really what it is it's operating system level virtualization. Essentially, it's like having a virtual machine. You get your own network interface, you have your own sort of file system sitting there, but all the containers share the same kernel. And so there's less overhead. You can spin up a new Ubuntu container in just a matter of minutes. And so it's really, you can set one up in a matter of minutes. Spinning it up and getting it running is seconds after you have it set up. And so it's a lighter form of virtualization. Multiple user space shared kernel. And it's an ecosystem as well. There's images that you can pull from the Docker Hub publicly. Some of those get updated, some of them don't when there's new vulnerabilities. And so there's tons of vulnerable images in the Docker Hub that people are using, that if you're aware of those vulnerabilities, you can find people using those images. Hey, there's your entrance into a Docker multi-container application to start playing around. And so Docker is sort of this wrapper of things around this technology that allows you to have containerization. Then above that, not in the scope of this talk, are your orchestration platforms like Kubernetes and Docker Swarm. We do a little Docker Swarm here in the demo. But ultimately, when you talk about a vulnerability in a piece of software, whether it's monolithic or container, multi-container, or anything like that, you have to look at the life cycle of vulnerability and where vulnerabilities come from. And vulnerabilities don't begin with the discovery of a vulnerability, they begin with a mistake. And that mistake that's being made that introduces a vulnerability into a piece of code when that software is developed, it's usually, typically, probably, I would venture to guess, mostly a result of a misunderstanding between two different layers of abstraction. And so you see over here on the right here, you have the user experience being typical users' expectations of how software works and their interactions with a computer. Below that, for that user, that computer's a magical box. They don't know the implementation, but they know how to work with it at their layer. The same thing happens with people who are familiar with scripting languages, or if you're looking at the implementation of an operating system, your interface with the operating system through its APIs. You have high-level languages languages like C and C++ that are compiled, and that sort of sits at a layer of abstraction closer to the metal than a scripting language does. Below that, you have things like, you're dealing with things like machine code and disassembled code and virtual memory spaces and things like that. And then underneath that, there's even more and more. It's turtles all the way down, right? And so you have ring 0, and then you have your hypervisors, and then you have, well, maybe that whole thing's running on a virtualization, so there's a hypervisor underneath that. You never know how far it goes down, but eventually it gets down to the point where it's bare metal, it's silicon, right? And so things that I wish I'd have had a degree in computer engineering instead of computer science for. And so you either misunderstand how one layer interacts with another. So if you're a C programmer, you write something and you think that it's going to handle your buffers for you and checking the links of things, and you don't understand stack frames, you don't understand saved frame pointers and instruction pointers and things like that. And so you just start putting stuff in there, and you've overwritten it, and you see a seg fault, and you're like, well, I've made a mistake. I went out of bounds on this thing. But an attacker who understands at a lower level of those stack frames, they're going to own you over that, right? They're going to figure out, okay, well, there's this critical data out here that's sitting on the stack that I have control over now. What can I do with that? And so the attacker typically works at a layer lower or even lower than that of the defender or the developer. And so if you're a hacker, if you're an attacker, pen tester, cyber criminal, whatever, how do you keep up with this sort of thing? And so there's a lot of technologies, and the whole adage of a defender has to be right all the time, an attacker only has to be right once. I won't argue with that in this talk, but really there's another adage, there's another issue here where a developer only has to know their platform and their language. An attacker has to be familiar with basically anything they could run up against. The team members that I have that do penetration tests, they don't get to choose the language that the target's implemented in. They have to learn PHP, they have to learn Ruby, they have to learn Python, they have to learn everything, PHP against their will, right? And so there's lots of languages and protocols and platforms and frameworks at varying levels of abstraction, and horizontally there's lots of different technologies at those layers. And so there's two dimensions there where your skills and attack can have gaps, and you need to always work towards filling those, even if it's something trendy and nonsense sounding, like super cloud or blockchain or containers and all the things that you see out in the Business Expo, right? And so if you're talking about development, movement, and abstraction in development, when you're developing an application, and if you're developing a web application, you can think of movement in these terms. Originally, you had people writing CGI binaries in C, right? As nasty as that sounds, as terrible of an idea as that sounds nowadays, people did that, and even nowadays on embedded systems, you're going to still find that. On top of that, you've got scripting languages that are a little more abstracted from that and a little bit safer, web-specific languages like PHP and JavaScript and things like that. Frameworks that are built on top of that. Think of things like Django that give you, that hide a lot of the database implementation, object implementation, underlying web protocols away from you. And then finally, nowadays, it seems like most web applications are implemented almost completely in JavaScript with just different little web APIs that they're making calls to. And so it's become easier to develop software. It's become abstracted away from the technology, the underlying low-level technology, and so developers continue moving upwards in this abstraction stack. When we're thinking about containerization, since we can take a WordPress container over here, we can take a database container over here, we can have a Redis container over there, and we can tie them all together, and we can have applications that talk to each other instead of having multiple threads or multiple forked processes for things running on the same system. I can have multiple parts of my application run on complete separate containers and talk to each other over TCP/IP. And so now the abstraction is that we have all those different layers that we had before, and now we have we can just put these applications together and build larger applications containerized. And so when you learn Hello World, as a developer or as a penetration tester, you take two different paths out of this. If you're a developer, you take that Hello World, that intro tutorial to a new technology, and you say, what can I build with these language constructs or the basics of this technology? Versus if you're a penetration tester or a red teamer or an application security specialist, what you should be thinking of is, how does this Hello World work now? Like, how can I play with this? And so playing around with it in terms of how Docker works is in terms of I did some intro tutorials, and we started putting together some simple applications and started realizing that there's some really interesting things there. So, for example, Redis is a piece of software you see a lot in these multi-container applications, and all it is, and I couldn't wrap my head around it first, but it turns out it's simple. It's just a key value store. It's like having a Python dictionary as a service, right? And so you give a key and a value, and it stores it off, and then you can have lists, you can have queues, you can have stacks, you can have just simple variables and arrays and things like that, and you push them over there by a TCP/IP, and you can fetch them back whenever you want to, and by default there's no authentication at all, but it's okay because it's all inside this containerized application, right? And so you get to think about that, and you're like, well, if I was writing a monolithic application, I'm storing all that on the stack. I'm storing all that in my memory space, and all these different functions and threads are sharing that memory space and accessing it like that. Well, now it's all over TCP/IP. So now, to read that data, instead of having to have a debugger attached, or having to inspect memory, or having to intercept things on a local host, I can manipulate the variables of a program through that. And all these containers are meant to be in such a state that they're atomic, in the sense that they're not meant to be modified, right? And so they're not meant to change over time, and every time you spin up a new container, it should be in a known state. And so to keep state, you have to have these things like Redis out there holding your state. And so manipulating it is important. And so as the average developer goes up the stack in the sense of using more and more abstracted technologies, those abstracted technologies become more important. Docker and containerization in general, Kubernetes, is going to become more and more important to application security testers. As a penetration tester, you're going to see more and more of these applications. So it's important you learn them. There's going to be new bug classes associated with this, just like every new language brings new bug classes. But it needs purposeful development and training. You actually have to go out and study this. I don't think there's any breaking Docker training classes out there yet. But the good news is for you is that your current level of knowledge, your current layer of abstraction that you're comfortable at is going to become more lucrative over time, because relative to that of the developer, it's becoming lower and lower on the stack. And the more you understand those mid-level things, the more you're going to be able to understand things that the average developer doesn't understand. And so we have control over execution, and as an application developer, if you're looking at a monolithic application, your goal is to gain code execution, and or to otherwise turn code against itself. A ROP chain is your classic example of that. If you're doing malware analysis, oftentimes you'll be instrumenting that binary. If you have at a higher level of abstraction, if you're looking at web APIs, you're writing code to call those web APIs directly to do interesting things. CSRF, you're making somebody else's browser do those things. And so now what we're looking at is you have this skill set that works at this level, but now your ability to do things between systems, man-in-the-middle attacks and these web API type things, that gets you into the insides of a newer application. And so it's a useful shift for attackers. Containerization, it allows for the design of applications that are composed of many independent single-purpose services. If you need more, so for example, in an application I'm making, I have several different agents grabbing information. It's an intelligence collection platform. It's grabbing tons of different information from different sources, and it's all kind of filtering up to a more centralized cluster of Elasticsearch instances. But to sort of kind of buffer all this out, and to take care of these different things, these agents may be in different locations and things like that, to store that data temporarily or to buffer it, you'll have these Redis containers around with queues in them that you're pushing data into, and eventually it gets popped out and pushed off to Elasticsearch and things like that. And so it's cheap for me to spin up a completely new container just to have a new data structure to play with. And so what this is doing is it's democratizing post-exploitation, manipulation, and instrumentation. If you were to break into this intelligence collection platform, which I don't intend for any of you to do, if you were to break into this thing, then without any authentication or anything like that in place, you would be able to have some manipulation of that. You can connect to Redis and start dumping a list of queries that are made to it. You can start poking at the data, reading it and writing it, just as if you were attached to me as a debugger, as a monolithic application, and not even have to interrupt the processing of the program. And so where the best way to look at it, and with all application security testing, you're sort of in this state where an application security test is very much like a penetration test on a microcosm, right? You think instead of hosts talking to hosts, authenticating to each other, trading data, and doing things with each other over various network protocols, you have functions that talk to each other via parameters. You have internal protocols and data structures that you have to figure out. A containerized app basically has those properties of an application, but it is implemented as if it were an organizational network. And so you break into a containerized app, now you have a whole new network to pen test. So exploitation of this is going to begin with a vulnerability in the surface level of your attack surface of your application. Not all of your containers will have ports exposed, hopefully. I mean, maybe you'll run into one that does, right? But you're only going to have certain ports exposed to the outside of this containerization, and that's going to be the user interface. And the vulnerabilities there is what's going to get you in. When I demo this stuff, there's no 0-day here. There's a Joomla vulnerability that we're going to use to get into this application. But ultimately, it's all standard web technology. It's all things that you know how to exploit. Post-exploitation, which is what we're interested in, once you gain access to one of those containers, you have free run of the rest of it. And it doesn't matter at the Docker level, apparently, what ports you've stated to be exposed or not exposed for each application or each container. If you're on that containerization network, you can talk to any of those things if you're one of the participants of that network, so if you're one of the other containers. And so you may not only have one application alongside you there, you may have multiple applications that's all hosted on the same host. And you can use the usual tools that you have, although it can be a little bit awkward because these containers are very stripped down. If you're used to playing around with BusyBox instead of a full suite of tools, you'll be fine. And you'll have to, but a lot of times you'll have to transfer tools over. And so Docker as a target attack, as a targeted application platform, so you can have a Docker application that's a monolithic application, and so that's the easiest way. You have something implemented already. You can deploy that thing that you used to do as a VM as a container pretty easily. And so you come up with a set of packages that it needs, you come up with the code base that it needs, and you can build a Docker file that builds that Docker image, and you can launch containers from it, and it's very easy to do that. But if you're developing for Docker, you develop in a mode where you have containers do very small single purpose things, and they all talk to each other because you can get free scaling with your orchestration platforms like Kubernetes. And internal to those Docker container networks, the default is if you're just firing off Docker run commands, or you have a simple shell script to bring it up, then you have one container network that all the Docker containers share. We'll look at a Docker Compose example that you can specify multiple different networks. And then the containers is defined what ports are published, but inside it, it's free game. The implications of this is, so through conventional exploits, it places you on an internal attack surface, and you have the opportunity to pivot, and it's familiar territory for you. From this point on, you're probably pretty good with your existing training. The issue here is that you're going to have to live more off the land than you did before. You're used to having more tools than are typically available in these Docker containers, unless they're really big ones, right? You can apt-get in everything, and some containers are like that. Some images are like that. But most people try to minimize the size of them, and so you'll have to transfer your own tools in. You're not going to find Nmap just sitting around on one, more than likely. And you need to learn to identify them. And so one of those heuristics for identifying that you might be on one of these types of systems, you break into it, and it's very minimalistic, right? It's a fully featured web application, but the shell is BusyBox, right? And so that's a hint that, maybe this isn't a typical Ubuntu server installation that we're dealing with here. But there's ways of identifying those networks, and the demo actually shows a command that you can use to sort of peek around in the proc file system and figure it out. But ultimately, you can also tell just by looking at the network layouts and other things that are sharing that private network with you. And so I have a demo here, and it's in the video form because there's a lot of moving parts, and I've tempted the demo gods before, and won, but this is a step too far. So it's multi-container application. The application is a voting application, dogs versus cats, that's typically used in Docker tutorials and trainings and things like that. It's out on GitHub. If you look at the white paper, you'll find links to it. I've modified it from cats versus dogs to red team versus blue team so that y'all can cheer and boo as necessary as this slides around. And what we're going to look at is we're going to look at attacking this thing externally using Kali and Metasploit to just get that initial foothold in, looking around in that network and manipulating the data structures. And I'm going to give you a tour of what's in there. I've inserted a vulnerable Joomla instance into this application to give us our initial foothold. The code base is so simple that there's really nothing to play around with in terms of that. But this is a version of Joomla that you can also see in the white paper. It's active on the Docker hub. It's not the official Joomla, but it's just some dude's Joomla, right? And so that's one of the problems with Docker hub is there's lots of this guy's web application, and he puts an image out there and he never updates it, right? So that's nothing against the person who put this particular Joomla out there. It served their purpose, and they're probably done with it. But it's also something that you're going to see people run into. So we've got a video here. I have to look over here to actually to start off and pause it. I'll try not to have to pause it. The idea here is we have a Docker Compose file sitting here. We have a number of applications. Each of these, hang on, let me try to. So each of these groupings here is a different container on there. There's a voting application written in Python. There's a results application written in Node. There's the Joomla instance we brought in. There's a worker, and they're all implemented in different, there's a .NET one in there, so they're all implemented in different languages and different technologies, and they intentionally do that to show you that you can have all these things interacting. You have that Redis server in there that's handling the votes and basically acts as the variable store, the global variables for all of these containers. And it starts up and using Docker Swarm, and you have this interface that allows you to vote between red team, blue team. No votes in, 50-50 right now. The Joomla instance that will eventually get our foothold into this with. And all these are running on different ports because they're different containers exposing their interfaces. We vote for red team first, red team 100%. We go back. We can actually change our vote. We have a cookie set that means that our vote can be this or this. And, assuming we've gone through all the rigmarole of finding this Joomla instance as an attacker and we want to poke at it, we want to break into this thing, we can load up the Metasploit framework. We make note of our IP addresses and everything locally because we're going to have a connect back with that. Anybody want to guess how many takes this took? Let's see. All right. So we set up our remote host and our local host. Just did the payloads for this, PHP interpreter for this. The Joomla application we're breaking is a PHP application. We have it phoning home to us, and it's relatively straightforward stuff here. We run it immediately, of course, our exploit works because we knew that there was a vulnerable instance there. And we see that we're sitting on what appears to be a Ubuntu system through sysinfo. If we drop to a shell, we can show you that if you poke around in proc a little bit, and then so if you look in the C groups of proc, and if you want to know about C groups, you can get into like the details of Docker and everything, but there's a lot of Docker references in that, and really that's like your heuristic for seeing, oh, this is kind of where I'm at. If you poked around on the file system enough, you'd see that it's pretty bare bones, pretty minimal. There's often a Docker file sitting in the root folder of your container, although you can change that. Again, looking at IP addresses. There's two separate networks there. There's the 1903 and the 1804. Those are two different interfaces. There's an external facing network on this network of applications, and then there's an internal interface for all of the things to talk to Redis. And Redis doesn't have an external interface, but once we've broken into one container, of course, then we can talk to the rest of them on that other interface. And so now we're on an interactive session with here. We're uploading Nmap to that Joomla instance because we want to explore that container network and see what it is that we can see in there, as far as what other containers are there. What can we interact with? What's our new attack surface? Our attack surface originally was those web interfaces and the Joomla instance that's there. Now that we've gotten past that, our new attack surface includes all of the exposed ports on applications that were not on the public-facing network. So here we do a full port scan of the first 10 hosts in the .18 network, and that shows us hosts that are up. And looking through there, we have there's names for some of them actually. There's you'll see that there's the voting app on the Frontier network. The DNS actually resolves some useful names for most of them. I think the Joomla, I didn't really give it a good name, so it just has sort of a randomly assigned name. So on the external side, that's what's external facing. That's the 18 network, this 172.18 network. Now 172.19, that's the inside tier in terms of this Docker compose file. This is what everything inside the network can see that you now can interact with that you couldn't before, and you get a lot more, right? And so there's a Postgres database in there. There's anything that you see labeled back tier there is something that wouldn't have been available otherwise. And also the Docker host up there, which, you know, there's the potential there for taking over the host machine for the Docker instance, depending on the version of Docker that's running. So now that we have looked around on there, we're going to, I believe, dig into the Redis instance. And so as votes are going into this system, it's a queue. So the votes are pushed on and then they're popped off into the database. And so when we start looking at this, we can forward a port from the outside of the network towards that inside of the network through that PHP interpreter. Here we're going to look at the Postgres database first. That's what we're up to. So I'm showing you a couple of different things you can tinker with. In the default Postgres Docker image, you know, in most Docker images in general, don't have any authentication built in. You have to set options for them. And so, are people going to do them? Maybe, maybe not. Even the tutorial on this doesn't. And so, of course, here we are playing around in the database. And so there's only one vote in there. The vote ID for the ID that we put in first, the vote is for A, which was for, I believe, red team. And we can insert a few more votes, right? And so once we've inserted those votes and quit out, we can look at this and see, now blue team's winning, right? So we logged in, we felt charitable towards blue, and inserted a few votes on that. Next, though, there's the Redis queue. The votes are being pushed in by the voting interface into the Redis queue and then popped out and be put in the database. So there's also the potential to manipulate it there. That's like your local variable storage for it. And so interacting with Redis is relatively simple. You can just netcat into that thing and start playing around. And you get a console, and monitor is a command that lets you see current things that are going on there. And so there's something that's consistently popping, looking to see if there's new votes in there. And every time you vote, and I'm off the screen here pushing the different votes, every time you vote, it pushes on right. R push pushes on the right, L pops it off the left and into the database. And so it's continuously popping, looking for new things. And so now we know that it's always looking for new things. We can R push ourselves. And that's exactly what I believe we're about to do. So we're netcatting back in, and then now we can simply R push in. And I'm off screen there copying, pasting out of Notepad a whole set of these R pushes. So yeah, go to town with it, right? And so all of them are votes for A, and all of them have unique voter IDs, which are not really in the same format as the other, but it doesn't matter for the purposes of this application. And so now red team's winning, of course. And so that shows you, after you break that external attack surface, you explore around and then you can start interacting with things. And as you're doing all these things, these are things that are the mechanics of it, the tools that you're using are things that you're probably familiar with as a penetration tester, but now you're working on the insides of an application. And so you're working at a lower relative level than the developers were. And so for takeaways for this, your existing offense-oriented skills are becoming useful at a lower relative position of abstraction relative to newer applications. And so if you're experienced with memory corruption and buffer overflow vulnerabilities and heap stuff and all that level of thing, issues with compiled languages, then congratulations, you're several layers underneath a typical application developer now, and you're going to be good at finding platform level vulnerabilities, and you're going to be good at finding vulnerabilities in binaries that are implemented in these systems that the developers of a multi-container application probably didn't even know that those binaries were even there. And so you have that aspect of it. The developers are moving up the stack, and even if you stay at the same place, you're in that new low level. If your experiences with scripting languages and vulnerabilities in PHP and vulnerabilities in web applications, then now you have that entrance into the rest of it. And using your host-to-host skills now after post-exploitation, you can move around in those applications. And so it's important to keep yourself up to date, though, because honestly, if it hadn't been for this, the first Docker host instance, the first multi-container application we would have run into, and we've run into some since doing this work. The first one we would have run into would have been on a client engagement. Right? And that's not the place you want to be. You want to be at the point where nothing's really surprising you on those engagements. Sure, you learn something new if you have to for the engagement, but it's better to come into it with that experience of being able to say, okay, I can thoroughly test this application, and I'm not using a client's time to learn this material. And so it's important to keep yourself up to date. And so even if technology seems like a trendy thing, as long as people are using it, as long as things you would classify as targets are using them, then then it's worth learning. And so chase those trendy technologies and look at the attack surfaces of them. All right, try to implement something in them yourself and learn how to develop for that. So, but ultimately this containerization, it represents an opportunity for attackers to leverage existing system and network level knowledge to explore these internals. And so I'd encourage you to continue working on those sorts of things. And luckily, it looks like before this is over with, I've got a little bit of time for question and answer in here. After that's over, then I'll take questions in the wrapper room. But my contact information is up here. These are the two best ways of getting in touch with me. My DMs are open on Twitter at McGrew Security, much to my dismay sometimes. My email goes straight to the phone. I always get a hold of it. And I've got cards if you're over in the wrapper room. The white paper that's associated with this, it goes into a lot of this stuff in a lot more detail than we can in the talk. That's available in the conference materials. It'll be up on our website, horncyber.com, within the next couple of days, if not today. And there's resources in there and lots of references. And so, this work's built onto the work of others, and so we can, I like to point people at other talks, other papers, other works on subjects so that they can get up to the same level I am. So if it's something that's in a reference in that white paper, it's something that I read.